Today we're going to look at surface area. So surface area and volume, a lot of times people confuse, but surface area would be like if you were to dip a 3D object into paint, what all would have paint on it? So we're just talking about the surface. We're not talking about filling it up, we're just talking about the outside. So we're going to look at the 5 big shapes. So first we're going to start with prisms. So really with the prism, one way to do it is just to find the sum of the areas of all the sides. So for instance, if I have 1, 2, 3, 4, 5 sides, then I would just find the area of each individual 5 parts, add them all together. This, by the way, is called a net. When you take a 3D object and you unfold it to see what it looks like, that's called a net, in case you don't remember that. So here's an example. So I would think about, when you have especially like rectangular prisms, you're going to have double sides. So for instance, this 6x5 side right here, I also have that up top here. So I'm going to have 6x5, and I have 2 of those. Okay, then I'm going to think about my left and my right. I would have 5x2 by 2 of those. And then I have 6x2, so like the front and the back. So 6x2 by 2 of those. So that gives me 60. This gives me 20. 24. If I add that together, that's 104 square inches. Okay, here's another scenario where sometimes you'll have double and sometimes you won't. So for instance, my 2 triangles, I have 2 triangles, one on the front, one on the back. So I would have 2 of the 1/2 base times height, where my base is 9 and my height is 12. Okay, but then I have what it's sitting on here. So this is going to be a 3x12 here. So I have a 3x12. Okay, I have this part here that's standing up, so it's a 3x9. And then finally I have the big slant here, like it's a slide, and that's a 3x15. Alright, so I can just go ahead and simplify this. So this would give me 108, this would give me 36, 3 times 9 is 27, 3 times 15 is 45. Okay, and now I can just go ahead and total that up. And you should get 216 square inches. Okay, so those are all prisms. The next shape we're going to look at is a cylinder. So I want to explain to you a little bit where this formula comes from. And I know I gave it to you, but you could also logic your way through this. So I have a picture here of like a cylinder kind of being unwrapped. Okay, so we obviously have a top and the bottom. So think about a can. Okay, so we have the top of the can and the bottom can. That's where we get our 2 circles from. Okay, so there's my 2 circles. But then the rest of it is called, it's like a soup label. Okay, so it's the label that goes around the can. So really, it's just one big rectangle. The length of this rectangle is actually wrapping around my circle, as you can see here. So this is just circumference. This is 2 pi r. The height of this rectangle is the height of my cylinder, or h. So 2 pi r h is where that, or that's where that part of the formula comes from, because it's just the soup label part. Okay, then the 2 pi r squared, that's because we have 2 circles, and pi r squared is just the area of 1 circle. So really we're just finding 2 circles, so the 2 bases, and then we're adding on the soup label. All right, so let's try a couple. All right, so I'm going to go ahead and write out my formula. So we had 2 pi r squared, that's my 2 bases, plus 2 pi r, that's the circumference times the height of my soup label, or that big rectangle, that lateral face. All right, so we have 2 times pi. My radius in this case is 4, so times 4 squared, plus 2 times pi times my radius again is 4, and my height is given to me as 7. All right, so I'm going to go ahead and simplify this here. So 4 squared is 16. 16 times 2 is 32 pi, plus 28 times 2 is 56 pi. So now I can add that together, and I would have 88 pi square inches. And you can go ahead and type that in your calculator if you want in round. If you're going to do that, I would make sure you use your pi button. But you should get 276.5 approximately square inches. All right, our next shape is a pyramid. Okay, so a pyramid, again, remember, has a polygon or the base, I'm sorry, is a polygon. Okay, then the faces are all triangles. So if I can find the area of my base, then I just need to find the area of all my different triangles. So the area of each triangle. So sometimes these are all the same if it's a square base, but if it's a rectangular base, they're going to be different. Okay, so you just have to kind of be careful there. All right, so we need the area of the base plus the sum of all my triangles. So in our case here, the surface area of the base, this is a square. If you notice, you have all those congruent marks. So the area of my base is 8 times 8 plus, now I have all my triangles here. Notice they're showing us that slant height on my triangle over here. Right here is the slant height on my triangle. Okay, that is the height of the triangle. So remember when it was laying flat? So the base of this triangle is an 8. The height of this triangle, remember the triangle, not the pyramid, the height of the triangle is 12. So I actually have 4 triangles of 1/2 with a base of 8 and a height of 12. Okay, so this is just one triangle here, but I actually have 4 that are all the same because my base and my heights are all the same. Okay, so let's simplify this. We have 64 plus, let's see, half of 8 is 4. 4 times 12 is 48. And 48 times 4 gives me 192. So 192 plus 64 then will give me 256. So 256 square inches. I think the surface area of pyramids is almost the toughest, just because you have to think of so many different little parts and components. But again, just one face at a time. Even if you ended up adding this one triangle 4 times, it'll still get you the same place. Next, we have the surface area of a cone. So I put out the net here for you. So we have this sector and we have a circle. So let's talk about where this pi RL plus pi r squared comes from. So the pi r squared here is from my circle. Okay, but the pi RL, let's look at that a little bit. So the pi RL comes from, if I were to take this sector and cut it into smaller sectors like we did with the area of a circle. So remember how we laid them out like this? We had them all laid out like this. Let me draw a couple here for us. Let's see, I need one more here. Okay, so remember how we talked about this scalloped edge here is half of my circumference of this circle? So that's half of 2 pi r. Now, the radius in this case here, this piece what we called radius before, that height is actually the slant height. That is part of the actual cone, like the wrapper of the cone. So this is actually slant height. So if I want to find the area of that parallelogram, it's going to be 1/2 times 2 times pi times r times L. Well, 1/2 times 2, that's just 1. So that's where we get the pi RL from. So that is the pi RL in that formula. Pi RL is for this big sector. The pi r squared is for the circle. All right, so surface area equals pi RL plus pi r squared. All right, so we have pi times my radius is 2. My slant height is 6 plus pi times my radius again is 2 squared. So we have 12 pi plus 4 pi. Gives me a total of 16 pi units squared. Okay, or again, you could multiply that all out if you wanted to. All right, so on this one here, surface area equals pi RL plus pi r squared. Notice this time I do not have that slant height. I need to find that slant height. So I'm going to need to use my Pythagorean theorem in order to get it. Okay, maybe if we had a special right triangle, we could do that, but we don't in this case. So I'm going to use my Pythagorean theorem. So a little side note here, 8 squared plus 15 squared equals my slant height squared. So when I get that, my slant height is 17. I'm going to do my Pythagorean theorem. So this is 17. So now we actually have all of our components. So the surface area equals pi times my radius is 8, my slant height is 17, plus pi times 8 squared. So we have 8 times 17, which gives me 136. So 136 pi plus 64 pi gives me a total of 200 pi square units. All right, so our next one is going to be the surface area of spheres and hemispheres. So the surface area of a sphere is 4 pi r squared. Now a hemisphere is half of that, right? But here's the catch. If I take 4 pi r squared and divide that by 2, I would get 2 pi r squared. But we have to be careful because that's really just the dome part. What happens when you have a hemisphere, when you cut that sphere in half, you actually expose a brand new surface here that you have to add back in that we didn't have before. So really, we had the 2 pi r squared from the dome part, then we have to add in another pi r squared. So keep in mind that coefficient there is 1. That means we have 3 pi r squared. So for a hemisphere, it's 3 pi r squared. For a sphere, it's 4 pi r squared. Nice thing is we have one variable here. So on the left here, my surface area is equal to 4 pi r squared. In our case here, my radius is 13. So 4 times pi times 13 squared. So 13 squared is 169 times 4 gives me 676 pi square units. For my hemisphere, remember my formula is 3 pi r squared. So that's 3 times pi times 6 squared. So I have 3 times pi times 36. Multiply that out, and I get 108. So surface area equals 108 pi square units. Okay, so yesterday in class you picked up those notes, obviously, and you also have the worksheet. So that's what you're going to work on today. Tomorrow then in class, we will go over the answers and any problems that you need to.